welcome welcome to this channel. Okay, so today we're going to learn how to differentiate a function that contains the natural log. So for example, we're going to use this. Okay, so now we need to know a few things before we start. We have two methods we can use, but this one, let's just stick to the easier one. It's easy but sure. We can easily get your score with it. So let's move on. So we have natural log, which is this of the function 6x squared plus 2x all raised to the power 7. So if you look at this closely, you can simply take the whole of this function, the function in the brackets, and make it u. So you say first of all, you have to make y equals natural log of 6x squared plus 2x all exponent 7. Then you say let u be equal to 6x squared plus 2x. So now we have y equals natural log of u exponent 7. So I'm going to use the chain rule for this. So we have to do dy du times du dx. So first of all, we differentiate this function first, then later we differentiate the u function second. You get it? So giving us dy dx for this. Okay, so dy, let's start with dy du. We know that when we have a function such as natural log of x, when you differentiate this dy of natural log of x, no y, all over dx, this gives you 1 over x, right? But first of all, we have y to be equal to natural log of u exponent 7, and according to the laws of logarithm, the rules of logarithm, when you have this, you can simply write it as y equals 7 natural log of u, right? So now this u over here is just replacing the x. It's the same thing, but just replacing the x. So now we write our dy du to be equal to 7 into bracket. Since this is a constant, just separate it from the function natural log of u. Okay, so 7 into bracket, then 1 over u. So dy du is now equal to 7 over u. You get it? Okay, now this is just representing the differential of natural log of u. Okay, now we move on. So now we have our dy du. Okay, so it's ticked. Now what we need next is the u and the x, and we have our u to be equal to 6x squared plus 2x, right? So now u equals 6x squared plus 2x. So du dx gives us 2 into bracket 6, right, times x exponent 2 minus 1 plus 2 into bracket the exponent of x, which is 1, times x exponent 1 minus 1, which is 0, and then anything exponent 0 we already know it to be 1, right? So let's take it to the top here. So now we have du dx to be equal to 12x plus 2 into bracket 1, which is the same as 2, right? Okay, so now we have our du dx ticked and dy du ticked, and then according to the chain rule, when we want to find dy dx, we have to multiply dy du times du dx. And when doing this, make sure the u and the other u, or the variables over there, are similar, so that if you cancel, you just be able to get the same thing as dy over dx, because this and this will cancel, giving you 1 times 1. Okay, so now we have dy dx to be equal to dy du. When we did it, we had 7 over u times du dx. We had this 12x plus 2. So we already know that u is 6x squared plus 2x, right? So now we get dy dx equals 7 into bracket 12x plus 2 all over u, which is 6x squared plus 6x squared plus 2x. Okay, so now get your dy dx. You can expand this if you want, but yeah, it's safe to expand. So you can get dy dx equals, from here you have 2, right? So 2 into bracket 7 into another bracket 6x plus 1 all over 2 out of here, so 2 into bracket 3x squared plus x. So you see that these two get rid of these two, so now you just be left with dy dx to be equal to 7 into bracket 6x plus 1 all over 3x squared plus x, bracket close. This is your answer. Thank you. Have a good day. Subscribe for more.